In this question on MyOpenMath, we're going to calculate probabilities from a normal distribution and a t-distribution. And then we're also going to calculate values, what are called z-values, given probability using the normal distribution and the t-distribution. To help illustrate that, we're going to use this website, onlinestatbook.com. It's really cool to help us with this. And of course, we're going to use Excel because this course is intended to help you do business statistics in Excel. So the first question is, we want to know the probability of being less than negative 2.01 standard deviations below the mean. So what this looks like is we're going to paste this value into this website here. I'm going to click on below. And so this area here represents the probability that we are 2.01 standard deviations below the mean. So the negative means we're below the mean. 2.01 means we're 2.01 standard deviations below the mean. And that probability is 0.222. I'm going to paste it right there. And then I'm going to copy this into Excel to show you how to do this in Excel. I'll copy it right into here. And then I'm going to type in the negative 2.01. And the true says use the cumulative version, which is what you normally 99 times out of 100 will use when you're doing these kinds of problems. So rarely, I've never actually ever used this situation where I type in false. I've never used that right there. So I kind of wish Excel would make it easier and just have one input, right? 2.01. But I digress. So I'll click on true there and then close the parenthesis. And we will get 0.0222, right? So the value on the number line is negative 2.01. The area is the probability, 0.222. Okay, moving on to the next question. Now we want to know the probability of being more than 2.01 standard deviations above the mean. So now I'm going to type 2.01. I'm going to click on above. And notice it flips and the probability is the same. That means this distribution is symmetric. So it has a skew of 0. Okay, then in Excel, how do we get this? Well, if I type norm dist 2.01, I get 99 or 0.9778. Let's go back to our diagram here. So what's going on here is that Excel is calculating the cumulative probability. So on the number line is 2.01. This gray area is 0.9778. And that's exactly what Excel gives you, 0.9778. So if you're doing this in Excel, what we'd want to do is you want to get the tail in the upper, you want to get the probability in the upper tail, not the probability in the lower tail. So we know that the area under distribution is 1. So if I subtract this from 1, I get the 0.2222. So this right here would be that area. Not doing that would mean I've calculated this area. Okay. Now I want to calculate the probability of being within 2.01 standard deviations of the mean. So now we're going down here to between. I'm going to change this to 2.01, negative 2.01. I'm going to change this to 2.01. And we get 0.9556. So that is this gray area, 0.9556. Now, this area here is 0.001. 0.0222. This area here is 0.0222. And the area in the middle is 0.9556. So visually, what are we doing here? Well, if I know this area, I can add it to that area and then subtract that sum from 1. And that's what I'm going to do in Excel. So I'm going to go over here to Excel. I'll change this back to negative 2.01. And that is that area. It is also that area. So I'll times it by 2. So now I have that area plus that area. And then I'll subtract this from 1. And I get 0.9556, the area in the middle. Okay, now for the next set of problems, let's go ahead and hit enter or submit to see if we got these correct. And we did. So now we're going to move on to the next set of problems. Okay, now we want to find the value of z such that the probability of being less than it equals 0.20. So I'm giving you, let's change this here. If I type in -1 there, at -1, right, the probability is 0.1587. So I'm giving this probability. This probability is 0.1587. I want to know what this value is. So let's just add 0.5 to that value. We'll make it negative 0.5 and see what happens. So if the z value is negative 0.5, the probability is 0.3085. We went too far, haven't we? So this area is too big. So let's try negative 0.75, see what happens. So at negative 0.75, this area is 0.2266, still bigger than 0.2. So let's try negative 0.85. So when this value here is negative 0.85, this value is 0.1977. We're getting really close. Is there a better way to do it? Well, yeah. On the same website, they have what's called the inverse normal distribution. Here, what you do is you type in the area to the left, and it gives you the z value, which is really close to what we were guessing over here, right? We typed in negative 0.85, and we got something close to 0.2, right? Now we type in exactly 0.2, and we get negative 0.841. So again, in review, that area is 0.20, the probability, and the number on the number line is negative 0.841. That's just, it's pretty close to -1. All right. Now, how do we do it in Excel? Let's check it out. We have to go to the top here and get the norm.s.inverse function. And all we do is we type in 0.2 close parenthesis, and we get, well, to 3 decimals, negative 0.842. Yeah, I think the calculator there is wrong. Let's try this. The website looks like it's wrong. Yeah, the website has a little bit of a rounding issue, it looks like, but it's great for visuals, right? It's off by just a little bit. Let's go to here and try typing in negative 0.842 and see what happens. Yeah, we get 0.1999, right? Let's type in negative 0.841. What do we get? 0.2002. So this is 0.0002 more than we wanted. And this is 0.0001 less than we wanted. So Excel is actually more accurate than this website. Okay, and I'm training you how to use Excel. So we'll go with the Excel numbers. Now we want to find the values of minus z and z to 3 decimal places, such that the probability of being between them is 0.4. So what we want is, let's go over here. We want the area. Let's just try some numbers here. Let's try negative 0.842 and 0.842 and see what happens. So the area between these two numbers here is 0.600. This down here is 0.2. This is 0.6. And this is 0.2. 0.2 plus 0.6 plus 0.2 is 1. But we want the area between them to be 0.4. So let's go to, okay, so we want this area to be 0.4. If this area is 0.4, this must be 0.3, and that must be 0.3, right? 0.3, 0.4, 0.3. 0.3 and 0.3 is 0.6. And this area here would be 0.4. So we'd have a total area under the curve of 1.0. So let's go to Excel. So what we're going to do here is we're going to copy, again, norm.s.inverse. And we're going to type 0.3. Why am I typing 0.3? Because remember, we want the area in between to be 0.4. So that means that's 0.3 and that's 0.3. And this is going to give us a negative number. It actually gives us a negative number, negative 0.52. 2 decimal places, or 3 decimal places. So negative 0.524 and positive 0.524. Let's go back here and try to figure out what's going on wrong with this. This is given an area of 0.5. Let's go up here below. Now this is weird because this is 0.3. So this agrees with Excel. Above is 0.3. So if I do this, I should get, yeah, okay. For some reason, we're working now. No, 0.4. It wasn't doing that before. Okay, so below this number here of negative 0.524, I get a probability of 0.30. Above 0.524, I get a probability of 0.3001. And then in between these two, I get a probability of 0.400 if I round to 3 decimal places. So these should be the correct answers. Again, to do this in Excel, what you do is you use this norm.s.inverse function and you put in 0.3 because that's the area of this white area. And then you use symmetry. So this number is negative 0.524 and this number is 0.524. And let's just hit enter to see if we got it right. And we did. Cool. Now, with a sample size equal to 30, find the value of t to 3 decimal places such that the probability of being less than or equals 0.2. So This is equivalent. This is kind of equivalent to what? This question. Here we find the value of z to 3 decimal places such that the probability of being less than it equals 0.2. Here, we're going to find the value of t to 3 decimal places such that the probability of being less than it equals 0.2. So this number should be really close to that number. But a t distribution assumes that you don't know you have to use a t distribution when you don't know the true value of the standard deviation. If you have an estimate of the mean and you're trying to compute, like, say, a confidence interval, you use a z. When you use a z, you're assuming that the standard deviation from the sample is the population standard deviation. Well, if you don't know the population mean, how are you going to know the sample standard deviation? So the t distribution is used when sigma is unknown. Sigma is the population standard deviation. Okay, and the interesting thing is, as the sample size gets bigger and bigger and bigger, the t distribution becomes the normal distribution. So we're going to see that at a low sample size, the t value here is going to be kind of close to that. But when we get a bigger sample size, we're going to see that the t value is a lot closer to this than that one. Okay, so because the sample standard deviation uses an estimate for the population mean, we have to subtract 1 from the sample size to get what's called the degrees of freedom. So the degrees of freedom in these two problems is 29. And that's what you use as an input to the t formula. So if you notice up here, the t distribution has 2 commas, whereas the standard normal distribution has 1 comma. So we're going to copy this up here, and we're going to paste it down here. Okay, and then I'm going to do the below here. And let's go over here. The area is 0.2, below negative 0.841. So when we do this in Excel, we should get something that's close to negative 0.841. So the probability is, whoop, I got the wrong one. We need to use t inverse. So the probability we're given is 0.20. And the next thing we're given is the degrees of freedom. Remember, I said the degrees of freedom are the sample size minus 1. In our case, our sample size is 30, but we got to subtract off 1 because, again, the standard deviation is using, and the standard deviation equation is using the sample mean instead of the true population mean to calculate the sample standard deviation. So we're using one estimate, and we have to add a little, because sample means vary around the true population mean, we have to add in a little variability, and this adds in a little variability. And again, we should expect this to be really close to negative 0.842, and it is equal to negative 0.854. So it's really close, isn't it? Okay, we're going to go ahead and jump to this problem down here, because all we're going to do is we're going to change the sample size to 200 and find out what happens to the t value. So we're going to change the sample size from 30 to 200. Now our degrees of freedom are 199. When we hit this, we should get something really, really close to negative 0.842. And we get negative 0.843. Hit enter to see if we got them right. Okay, we got both those right. Now, these two questions are very similar to this question. So these t values should be close to these. But down here, because the sample size is bigger, this t-value should be even closer to that, and this t-value should be even closer to that. So, again, we want to know what the minus t and the t are that gives a probability of being between them equal to 0.4. So let's go back here to between. Okay, so the area between negative 0.524 and positive 5.24 is, to 3 decimal places, 0.4. So our t-value should be pretty close to these two values, negative 0.524 and 0.524. So let's go back up here. And remember what this area is here. What is this area? If this right here is 0.40, this must be 0.3, and this must be 0.3. So what we have to do here is we have to change this to 0.3. We have to change this back to 30, right? And again, we should get something that's really close to 0.524. Review, if this is the t-distribution, and this area here is 0.4, this area here is 0.3, which is why we have 0.3 here. Unlike the normal inverse formula in Excel, which only has one input, the t has 2 inputs, so we need to put in the degrees of freedom there. We hit enter and we get negative 0.530. And that's pretty close to that value right there, right? Now, due to symmetry, we just get rid of the negative sign. And I'm going to hit enter to see what we got. You get it right. We're good to go. Cool, awesome. Now all we have to do is change the 30 sample size to 200. And we get negative 0.525, which is pretty darn close to these two values, right? And we don't need a negative for that. I hit enter, and I have them all correct. Thank you.